Well, this session was packed, and I think it set the stage for the following sessions, but we do have a few minutes for any questions and discussions. So if you have any questions, please come to the microphones that are here in the aisles. And those of you online, if you have any questions, you can send those questions to us, and we'll be able to get answers for you. If you could state your name and where you're from. Thank you.
Hi, I'm Norman Peterson from MedImmune, and my question's directed to Dr. I'm Norman Peterson from MedImmune, and my question's directed to Dr. Kaufmann. Pharmacy has a great interest in investing in digital medicine, some of the things that Dr. Califf pointed out, and gathering that information because, you know, it's important for us to identify which subpopulations are responding to our diseases and which ones are not. So I was just curious, on your list of people that you're collaborating, supporting, and working with, I didn't see any pharma companies, and I was just wondering if NCATS is working with pharma, and of course, what are some of the barriers that may be present, such as sharing information, that type of thing. So if you'd comment on your interactions with pharma.
Thank you. That's an excellent point. The All of Us initiative, of course, is not run out of NCATS, but it's a broader NIH initiative, as you know. At NCATS, certainly, and I think across the NIH, we realize that new treatments will ultimately often not be brought to patients by academic researchers alone, but they have to be handed off, and there has to be strong frameworks for private-public partnerships. I think that absolutely it would be in the best interest of the public then if we had more continuity. And Dr. Califf spoke of a regulator's dream, and we could perhaps speak of a research dream where there would be an ecosystem where there is more continuity of data, where maybe, you know, patient groups who have registries where they collect data use upstream a framework of standards, governance structure, consent structure that would facilitate the downstream connecting of such data sets with, for example, natural history data sets that are funded by the NIH and collected by academic researchers. And that in turn, ideally in a utopian world, would be set up using the same guiding principles of standards and user agreements and data sharing frameworks, that it would speak to industry data sets. Because of course, industry, when a new treatment is on the horizon, needs to have strong data sets that lend themselves to a regulatory evaluation. And then now even, for example, in rare diseases with more conditional or accelerated approval pathways, there's also a need often for post-marketing gathering of evidence, not only for safety, but increasingly also for efficacy. So I think, yes, absolutely, if we could, as a society, figure out a way of aligning the incentives and figuring out what part of the way we can walk together. Where is there, the word pre-competitive is sometimes used, where is there a space where we could all agree that this is a good thing to kind of walk together? And then the IP and the incentives for branching out come at a later point. And I hope that the Precision Medicine Initiative will help in a way be pushing the envelope in that direction. But yes, we recognize that we are not about just bench to bookshelf, we are about bench to better health. And therefore would love to, and we can maybe talk in the break more, would love to see more of this kind of engagement between private and public partners, a way to be transparent about it, to address any potential conflicts, bring them out in the sunshine, and create ways how to manage these conflicts in a way that will help us bring more discoveries to health benefit.
Thank you.
Go ahead.
My name is Lee Chang. I'm from Penn State. College of Medicine, and I am a physician scientist, do research with zebrafish, and work with imaging. In clinical medicine and in our animal work, we look at phenotype. Patient comes in with some symptoms, and you can make some measurements of phenotype. And I was wondering if, other than the molecular anchor that we currently favor, we might consider phenotypic anchors, because phenotype is influenced by both genes and environment. So it seems to me the middle should be phenotype. Wondering what you have to say about that.
I'd say I agree absolutely, and that I think is really the key and the vision to be able to connect all of those from the molecular basis and understanding and data sets, as well as the clinical outcome, the test, what worked and what didn't work, what were the side effects and things you're seeing in the clinic, and then also in the more consumer space and just in your daily life, the environment and behavioral. And so being able to put all of those together, and that's where you really get the new insights and are able to accelerate discovery and then put that back into application. And so I agree completely. Those have to be really integrated and coordinated.
Thank you. Next question.
Jim Stevens, Eli Lilly. I'm a classically trained pharmacologist circa 1975 to 80 who's now been in computational biology for the last 10 years. Do you think we have a larger problem in collecting data or a bigger problem in how we actually use the data to solve important biological problems? And if you have a bias one way or the other, what do we do about it? I don't see a challenge in collecting more data, so you can clearly tell from my question which way I'm leaning.
Yeah, this is Rob. I might just comment. I mean, that was one of the main purposes of my talk, is to reinforce what you just said. We have this tremendous potential. It's multidimensional and almost overwhelming. Yet at the same time, on average, our major recommendations for patients are not based on high quality evidence. So the translation of this is quite a challenge.
So I don't know that I have a view, lean one way or the other. I think it really is both. We need to be collecting those different types of data, and then the step of how do you actually translate that data into knowledge that is actionable and is truly based on evidence. When the precision medicine report and kind of that vision was put forward, there was some certainly in terms of computational capabilities present, but I think we've really come a long way in terms of AI. And so I think that how you analyze that data, and certainly not to replace in any way researchers or clinicians, but really to help facilitate that discoveries and application, I think is really important. And that you still do very much need the basic research, the animal models, and asking those questions. Once you see a connection, or and then you need to take that the step further to say, is this real? I mean, okay, this raises an interesting trend. It looks like this gene and this environment or behavior, that there's some correlations there, but then doing the research to really validate that and ask that in a more specific way, I think is still essential. I wanted to mention with the original precision, mapping the human genome report, I think they didn't mention PCR in that report. When they were calling for the human genome, it was around. I think they discussed it. It's either not mentioned very much or only maybe once in that whole report. And so I think that is, and as I said, likewise, I think the toward precision medicine report, there's not as much. There's some, but discussion of specifically AI or mobile technologies. And so I think also. Think that when you outline those kind of questions, that we really do have to have the technologies help catch up and enable us to actually do those things that we've put forward as the vision.
Thanks.
I think not to try to answer your question, but to add to it, we also have the challenge of the fast-moving pace of development of both computational science and informatics. And we tend to make plans based on the technology we have today without knowing what's coming. And it grows exponentially.
To build on that, my impression is the only thing that grows faster than the data set is the number of different algorithms and methodologies one uses to analyze it. And they all are slightly different, so there's really no consensus on, we all agree this is the way we should analyze this data set. And frankly, we weren't trained that way. We were trained to find new ways to do things. That's the way we function as scientists, both within the academic and industrial communities. Yet to solve the problem, it requires some kind of consensus and cooperative behavior to make sure that we land on, let's use this methodology for a while, see how far we get in this conversation between the computational scientists and the biologists, rather than continue to proliferate the database and proliferate the number of algorithms endlessly.
And we can take a little bit of comfort in knowing that NASA has gone before us, but trying not to repeat their model, where there are huge warehouses full of data on tape and cards, using the best technology at the time to collect data that we can no longer access.
Okay. Well, this has been a very interesting session. I want to thank all of the speakers in today's session, and also thank you for your participation. The speakers will be here still for a little while at least. So I'd encourage everyone, let's take a break, get coffee outside, continue your discussions, and then let's be back here by 10:30 to begin our second session. Thank you.